Alright, so we're going to continue on with Unit 2.1. Today we're going to start with Chapter 12, Section 1. We're going to talk about forces. So exactly what is a force? It's considered to be a push or a pull that acts on an object. So it can cause a resting object to move, or it can cause an already moving object to accelerate or decelerate by changing speed or direction. Now we've talked about motion and we've talked about velocity, speed, and acceleration. We're still going to be using all of those things, but now we're going to add in more new pieces. So how do we measure force? The units for measuring force is in what we call newtons. You might see that as familiar from Sir Isaac Newton. And our symbol that we're going to put behind all of those numbers is capital N. So if you see 10 capital N, that's 10 newtons, that's a force. Now, how we're going to represent our forces, and we'll need to draw out some diagrams with this, we're going to represent our forces with arrows. And these arrows are going to represent two things for forces. The direction of the arrow should go in the same direction as the force, and the length of the arrow should give a decent scale of representing the magnitude or the number with units for the force. So obviously if you have a force of 10 newtons and a force of 5 newtons, one should be half as long as the other. So we're going to be combining forces in the same way that we were combining displacements. If they're in the same direction, you're going to add them together. If they're in the opposite direction, you're going to subtract them from one another. And then, of course, if they're in different directions, you can always graph those just like we did with displacement and find that force. Now, it does have a specific name when we combine all these forces, and we call it the net force. So think about your net pay for those of you who have a job. This when the overall force acting on the object is after all the forces are combined. So this is your end sum. So for those of you who have a job, you have a gross amount of income. Well, after they pull out taxes and insurance, all of this other thing, once they pull that out, what you're left with is your net pay. And that's the same situation as what we're talking about here with force. Now, there are two types of net force. We have what's known as balanced forces and unbalanced. Balanced is where all of the forces add up to be zero. So that means there's no change in the object's motion. Either it is not moving or it is moving at a steady pace. It's not slowing up, it's not slowing down, it's not speeding up, but it is staying the same. Unbalanced is the opposite of that. That means there is movement happening here. And we'll talk a little bit more about unbalanced forces once we get to Section 2. So the object is actually accelerating or decelerating. Now, another thing that we get into with forces is the force of friction. Friction is any force that opposes the motion you're moving in. So think about if you have socks on your feet and you're going across the carpet. You're creating friction between your socks and the carpet. It's opposing the motion or the direction that you are moving in. So in order to have friction, two objects have to be touching. Okay, so they have to touch as they move past each other. And we have 4 different types of friction. So static, sliding, rolling, and fluid. Static friction is when the object is not moving. So think about a couch or maybe one of my heavy filing cabinets in my classroom. Those things are things that are not moving. They're going to be really hard to move as well. And again, friction is always in the opposite direction of any applied force. Sliding friction, again, think about having socks on your feet and going through a hardwood floored house or on tile. You're going to slip and slide, right? So it's sliding over a surface. Sliding friction is less than static friction, means it moves more easily than something that's at static friction. Then we have rolling friction. So that means we have rolling objects that needs to have wheels or some type of turning movement to it. So think about a bowling ball, or my cart at the front of the room has wheels on it, so it's easy to move back and forth or change its position. And rolling friction is about 100 to 1,000 times easier than static or sliding friction. And then the last type is fluid friction. And fluid friction is, when I say fluid, I'm talking about a liquid or a gas. So think about moving through water. It's pretty easy to move through water, right? Think about air resistance. So moving through the air. When we're flying, you have some air resistance. Air is a gas. Air is actually fluid friction. A couple more things and then we'll be done. So we have gravity. It's an attractive force that acts between any two objects that have a mass. So it's an attractive force that's pulling you toward, for now, pulling us toward the earth, or maybe you're sitting closer to the person on your right than to the person on your left. So you have a stronger force of gravity between the person on your right than your left. So attractive forces. And Earth's gravity is always going to act downward toward the center of the earth. So we are being pulled toward the center of the earth. So when we're being pulled, we have what's known as falling objects, or objects that are in free fall. And these are objects that are going to accelerate downward. So they're accelerating toward the earth. And they are accelerating with a constant acceleration. Remember, we talked about constant acceleration when we talked about free fall from chapter 11. And we talked about that gravity, or the acceleration due to gravity, being 9.8 meters per second squared here on Earth. That's very important for you to remember. Now, when we're talking about falling objects, air resistance is acting in the opposite direction. So air resistance is actually slowing things down. So think about someone who's skydiving. If they pull their arms in really tight, they're going to go a lot faster than if they have their arms spread out as far as they can go to slow down their motion. So what happens when we have these falling objects falling toward the earth? We reach a point where we no longer gain speed. We're still falling, and we're still falling at the same rate. We still fall with 9.8 meters per second squared, but we have reached the maximum velocity possible. So what that is defined as is the constant velocity of a falling object when the force of air resistance equals the force of gravity. So what's pulling you down, the gravity that's pulling you down, you also have that same amount of air resistance pushing you back up. And if you'll notice, these two arrows are the exact same size. So keep that in mind for terminal velocity. So you've reached the fastest speed that you can go at that point. Last thing for today, projectile motion. So any object that's flying through the air on a curved pathway, we call a projectile. That's after it's given an initial forward velocity. So it's a curved pathway. It's known as projectile motion. And that's the last thing for today.